My name is Radu, and today we're going to have a deep dive into Brigade. I'm a software engineer at Microsoft. I'm an open source maintainer on a bunch of projects. Brigade is one of them, the Cloud Native Application Bundles, and some others. I'm a piano enthusiast. My neighbors don't like me very much because I'm learning. So today we're going to have a look at Brigade, and specifically we're going to take a look at a bit of an advanced scripting guide, right? How to do things that you wouldn't necessarily be able to do with YAML, for example. How Brigade works. We look at building custom gateways, take a look at securing Brigade, and then a bit of dependencies and strategies for testing Brigade. But before I get started, if you haven't seen the introduction to Brigade, or if you're not familiar to Brigade, I advise you to have a look when you go back home to the yesterday's session, the introduction to Brigade. But if you are not familiar, we think about an operating system as the thing that manages processes on a machine, right? Well, in the same way, we can think at Kubernetes as a thing that manages containers on a cluster, right? And if you go with the analogy a bit further, then if you ever done operating system shell scripting, like Bash or PowerShell, well, that gives me a flow control that I can wrap the execution of various processes, but it's not opinionated on what that process does. And essentially, it allows me to do something like this. I can start a process, ls, take each result in the output of it, do something with it, then use it as input for the next process. How would something like this look on Kubernetes? Well, I want to do the same thing, right? I want a flow control that wraps the execution of containers, but is not opinionated about what that container does, right? So ultimately, I'd like to be able to do something like this, to have a scripting programming language and have a scripting environment that allows me to do that. For each result of the executing container, use the output and start another container and use that output with it. How do people do that today on Kubernetes? Well, I've seen bash scripts in BusyBox. I've seen local bash scripts that do kubecontrol exec, then wait for that, then do a grep, and then do a kubecontrol exec again. That's not very maintainable and is not very testable. And I've seen people do things with YAML that no one should be able to do with YAML. We think that Brigade might be a fit if you have that trouble, if you're struggling with things like that. So Brigade is a Cloud Native Computing Foundation sandbox project. And essentially, it's a framework for event-driven scripting on top of Kubernetes. It is really, really lightweight, and it's built with Kubernetes native objects. Its purpose in the end is to allow you to chain together multiple containers and respond to certain events that are happening and create workflows. At the end of the day, you have a real programming language with real language features that allows you to start pods on Kubernetes. It allows you to do more advanced things such as pass storage, and we'll see that in a minute. Let's see exactly what I'm talking about, right? Is that large enough? OK. So this is the simplest Brigade script that you can write. And essentially what it does is it defines a new job called do nothing. It's going to pull a container using the image Alpine. Imagine you can use any container that you have access to pull, either from a public registry or from a private internal one. It defines the tasks that I want to run inside that container, and I just run it. For someone who's never seen Kubernetes before, starting job and scheduling things to run on top of Kubernetes is as easy as writing a couple of lines of JavaScript. And the goal is to make it as easy as possible for newcomers. But at the same time, if you know how to do things in Kubernetes, well, you have real language features. So for example, if you want to wait for a container to finish, for a pod on Kubernetes to finish before starting a new one, well, there's async await in JavaScript that you can use, right? On top of that, we also have an API called the Groups API, which essentially you can just define jobs and say, I want to run each of those in order. So if we run this thing, so I'm using the Brigade CLI called Brig, which essentially allows me to start the execution of flows manually. we're going to see in a minute how it's supposed to work and how we're supposed to react to actual real events. But essentially, I'm starting the scheduling of that script. And at this point, what we can do is we can use the web dashboard of Brigade and see that a build is started. And essentially, I go to that, and I can see the 2 jobs that started. If you're not that interested in web dashboards, we also have a CLI dashboard. So here's the latest thing that started. And I can see exactly that I waited it for the first job to finish, and then I started the second one. And from the same dashboard, I can see the jobs of whatever ran inside, right? Now, there are other things that I could do with Brigade. If you ever try to attach a persistent volume to multiple containers in a coherent flow, and that's a bit difficult, right? In Brigade, you can define that storage enabled equals true, and Brigade will automatically create a persistent volume and attach it to all jobs in a certain script, right? And we do that for you. So what this does, the first job will write in a shared file, the second one would write as well, and then the third one will display whatever happened after the execution of those 2. So I can do something like this and see that the build is running. What's happening right now, Brigade is creating the persistent volume. It's waiting for that to be created. It's going to attach it to each of the jobs that are running. So the first one succeeded. It just wrote on a file, right? It didn't do anything else other than that. I can go to Brigade term. And the third job, I can see the output of all of the jobs that I attached the persistent volume to. Because Brigade is built on Kubernetes and understands Kubernetes objects, attaching a secret, something that's trivial, and usually in any non-trivial example, I'm going to need to talk to a database or talk to a storage account. I'm going to need credentials and secrets, right? It's as simple as referencing a secret in the environment, right? You should not do that, probably echo secrets, right? But Brigade allows you to do. If you're an administrator of a Brigade installation, you can prevent that from happening, right? You can set that for all of the jobs that are running, no one can mount secrets, right? And Brigade gives you that ability. Because it's a programming language, you can have something like try-catch, retry policies, you can catch exceptions and recover from failures. What this job is going to do is going to start the first one, and it's going to exit successfully. But the second one is going to exit with an exit code 1, which is failure, right? I can do a try and try to run those. And in case of an exception, log the exception and then maybe do some cleanup. Let's see that in action. I kicked off the script. And if I go back to the CLI dashboard, I can see the first one, which was successful. And I can see the second one failed, right? Let's go back to the web dashboard and see that we actually recovered from that failure. We can see the pod failed, right? The second job failed. But I caught the exception. And at this point, I can do anything I want. I can do a cleanup process. I can retry if I wanted to. Another thing that you can do is define base jobs. If someone in your company is responsible for building this, they have to understand how they're supposed to build it. And then other people can just use it, can instantiate it with new job. And that's it. It's going to run whatever it was declared to do. But how does Brigade actually work, right? I said in the beginning that it's an event-driven scripting environment for Kubernetes, right? The events have to come from somewhere, right? Whenever there's an event triggered outside of a Brigade, they can be webhooks, they can be any event source that you might want to respond to, and we'll see in a minute what is that. There's a component in Brigade called a gateway, which will map the external events to a Brigade event, and then your JavaScript file will get executed and Kubernetes pods will get started. Specifically, the gateway is a component that translates the events. After the event arrived and it was transformed by a gateway, there's a Kubernetes controller that listens for those events, and then it will start a pod to execute your JavaScript file. At that point, executing the JavaScript file will create Kubernetes pods that the JavaScript file manages and schedules. And on top of that, there's an API that you saw with the web dashboard and the CLI. So essentially, this is how it runs. Where the events come from? Well, out of the box, Brigade comes with a couple of gateways, things that understand the outside world. There's a generic gateway that understands any arbitrary payload, JSON payload that you might have. If you have a system that generates JSON, you have an out-of-the-box thing that can map to Brigade events. The same gateway also supports cloud events, which is a CNCF specification for standardizing JSON schema payloads. All cloud providers support it. We support it as well. So if you have, for example, a storage bucket that generates an event, you can catch it with Brigade out of the box. These events, they can come from webhooks, from HTTP triggers. But ultimately, any application that can create a Kubernetes secret can create Brigade events. Ultimately, Brigade events are just Kubernetes secrets with a special label and a type, right? We do that for a number of reasons. I'm going to get into it. But you have examples. All of our production gateways are built with Go. We have examples on how to do it with Node.js. You can do it in Bash by creating a secret, right? And we have examples for Python as well. If, for example, you want to respond to, I don't know, a Kafka event, well, there's a Python gateway that does that for you. All you have to do is be close to the source of the event, catch that event from the outside, and be able to create a Kubernetes secret. And that's it. So let's see how a custom gateway actually looks like. So I told you that you can write anything you want, even a Bash script that creates an event. Ultimately, it's just a secret, right, with a couple of labels and types, right? If you can create a Kubernetes secret with that, then Brigade is going to understand it, the controller will pick it up, and will start executing your script. But let's have something a bit more testable that we can reason about, right? We have a getting started for gateways written in Node.js. And essentially what this does is it waits for a post request, and whenever one comes with a project name, it will create a Brigade event. And very similar to what you see in the Bash script, the creation of the Brigade event itself, it's just the Kubernetes create a namespace secret, right? It's the same thing. If you manage to create this in any language, then you have a gateway. You saw me earlier using Brig, the CLI for Brigade. Brig acts like a gateway. I just simulate events on my command line. Brigade catches those and starts whatever script I defined. So essentially, if I start this web application, and it started on port 8080, I can do something like a curl with a post. My event was accepted, and I can go back to the CLI and I can see that 2 seconds ago, an event was created with the name Node Gateway. That was the source of the event. So whatever application you have that connects to outside events, to external things, if you can create a Kubernetes secret to map it inside the cluster, Brigade will pick it up. Now, let's talk a bit about how to secure a Brigade environment, right? Ultimately, Brigade is built on top of Kubernetes. It's a Kubernetes application. It's built with a controller, which is a component. There's an API, and there are worker pods that get created, right, to schedule your jobs, the things that you want to execute. Well, because it's a Kubernetes application, you treat it just like any other Kubernetes application, right? Our recommendation is to isolate Brigade in a single namespace. We can talk about the reasons if you want to. Ideally, you want to use RBAC, roles-based access control. It's enabled by default, and you should probably use it. If you have external gateways that accept events from the outside, always use HTTPS. We have a documentation with a tutorial on how to use Cert Manager, Nginx Ingress Controller, and how to configure DNS using Cloudflare. So you can swap any of those components out with your own, and you can still you can still do it. A really important point. Brigade allows you to start container jobs, right? They allow you to pull a container image from your container registry or from the outside and start it in your cluster. Always use images that you trust. They will start in your cluster, right? You don't want to use things that might have vulnerabilities in them, that can exploit things in your cluster. And another really, really important point. Always validate user input and always authenticate events. Here's the scenario, right? You have an external gateway that creates Brigade events. The Brigade event gets picked up by the controller and then starts the things that you want to execute, starts multiple workloads on Kubernetes. If someone finds out your endpoint, they might be able to start a lot of things in your cluster, right? Always authenticate that the source of the event, the sort of the event that, sort of the webhook or whatever type of system you have for the event, is authenticated to do that. Use a secret, use authentication tokens. We have examples on how to do that as well. Now, because Brigade is actually running in a JavaScript environment, you've controlled the flow using JavaScript. And because you're able to, I showed you how to create a specific class of job that is already defined by someone and you can just start it. Well, you can use dependencies in your brigade.js file. You can import JavaScript modules, either locally that someone from the same repo that are defined, or you can pull packages from NPM or any registry, actually, right? If the thing to note here is that those are pulled every time you have an execution. If the thing takes a long time, or you know that you're going to use the event a lot, you might want to consider building that package directly into the image so they don't pull it every time. Important here is you should avoid putting too much logic in brigade.js. Its purpose in the end is to control the flow and start things, workloads on your cluster. When possible, start the jobs with the custom logic inside Kubernetes jobs. And let's see how a Brigade pipeline, a Brigade script with external dependencies looks like. This is my brigade.js file. I require Brigadier, which is the library that defines job and group and things that allow me to start Brigade jobs. But I also require something called is13, which is a very useful NPM package that checks if a number is 13. It's a really useful package. And then I also require something that's local. It's .localDepCircle. And if I go there, I can see there's a very simple Node.js module which exports two simple files, right? That do something that calculate the area. Where did I define is13? Well, there's a brigade.json file which has a field for dependencies. If this is present in your project, whenever there's a build scheduled, Brigade will read the script and will install the package that you define here, right? There's also strategies if you want to connect to private registries. There's an open issue for that with detailed steps on how to do it. So let's actually run this and see what's happening. I started the event, and if I go to the web dashboard, I see the event is running. It started a few seconds ago. Brigade detected that I had the dependency. It pulled the dependency from NPM. It started it, and then it executed the script, which actually used both of those things. It used the event, it used the package from NPM, and it also used my local thing. Again, avoid putting too much logic in your brigade.js. When possible, always offload that to Kubernetes pods. Now, one thing that's always better to have than not to is to actually test the things that are into your system, right? Because Brigade is written with JavaScript, you can actually unit test the scripts that you provide. There's a project called BrigTest. Its purpose is to check that Brigade.js, first of all, is well built, that it doesn't have syntax errors, that it uses the actual things that are defined in your environment. And it also automatically executes the unit tests for you. It does not run the things that you define to schedule on the cluster. You can mock them, and it does not need Kubernetes for that. There's also a tool called Brigade Integration Test that someone from the community built. Essentially, it uses Minikube. It automatically configures Brigade. It creates the project. It creates events and checks that the output of the event is actually what you intended. It's using, I think, BATS, the Bash testing framework. And essentially, it allows you to functionally test everything that's happening in your pipeline. We have built-in support for the CNCF cloud event specification to define events. We have integration with the GitHub API. We actually use Brigade quite extensively for our own development purposes. This is running in GitHub, right? This is the Brigade repo. For every pull request, there are builds. The pull request is an event for us, right? We kick off a build that's happening in our cluster, in our subscription that we manage. It's not in a public cluster. It can be in a public cloud. It can be in a private cloud, in your own local environment. It runs the jobs, and then it posts the logs back to GitHub so that anyone can actually see the things that are running. If the thing that you're trying to integrate with supports this, you can do it with anything. And we did it with GitHub because, well, we use GitHub. We also have integrations with Prometheus and Virtual Kubelet. Both of them are CNCF projects. And if your system generates arbitrary payload of JSON, you can catch that as well. There are a lot of tools that I've shown you. I've shown you the web dashboard, the CLI dashboard. I've shown you a few gateways. Most of them are built by the community with us. If you want to contribute your own, we're happy to help you get started. You can find the docs on docs.brigade.sh. And this is the moment where I just shout out to Ronan from our team, who builds awesome documentation websites. If you want to contribute, we have a couple of issues labeled Good First Issue. We'd be more than happy to help you get started with the development environment and actually contribute things. And we actually want you to get involved, right? We have a Brigade channel in the Kubernetes Slack. We have a bi-weekly community meetings at Tuesday at 6 p.m. Central European, which is this time zone. And you can find the repo on Brigade Core Brigade. Questions?
Hi, so just real quick, how big is the footprint of Brigade within the cluster?
So within the cluster specifically, Brigade has, technically it has only one component that needs to run all the time, which is the controller that listens for events. And that's the only thing that needs to be running. You probably also need another pod to actually generate the event. But other than that, there are two pods, right? The moment the event is generated, the controller creates the worker pod, which executes your JavaScript script. And that generates another Kubernetes pods, other Kubernetes pods. So essentially, there are two pods that are required. And then optionally, you have the API to have web dashboards and things like that. Specifically, 3 pods that are running in your cluster.
OK, and the secrets that get created as tasks, basically, do they get removed after the execution? Or?
We have a vacuum that runs every hour, and you can choose to delete those as well. There are companies, there are scenarios where you want to have those. There are scenarios where you don't. You can delete the pods that were created, you can delete the secrets. It's up to you.
Yeah, I wanted to know if how would you compare this to Knative, and why would you choose one over the other?
OK, this is on mic. The comparison with Knative, there's also comparison with Argo that usually comes up. Essentially, the minute you want to actually execute things, and the minute you're not only declarative, the minute you have to execute something, check the status, pass information between multiple pods, recovery, retry policies, try catch, you need a real programming language, right? If you need that, then probably Brigade is the right thing. I've seen people do things with YAML that are insane. If you want something that's testable and maintainable, maybe have a look at Brigade. Thank Thank you.
So do you have any tooling to replay events? If you have a pipeline with long-running jobs that take maybe 20 minutes, half an hour, or something like that, and then somewhere in the middle it fails, I don't want to redo everything.
We have an open issue for that, and we've been discussing it for a couple of months now. It's not implemented. We'd love to see the scenario and the requirements for that. We're actively looking into it.
And can you speak a little bit more about this choice between declarative and imperative? Because so it's true that you can add like error handling and retries and stuff, but some part of this declarative approach has been that the controller handles that and not the user. So now the user needs to add this logic to what the retry should be, and it's not the controller.
Well, ultimately, if the person running the workload, that's the person who ultimately knows the retry policies and what's the cleanup for that thing, right? That's the approach that we're trying to take.
And so is this using the Kubernetes jobs API, or are you scheduling pods directly?
It's scheduling directly pods.
Okay.
So jobs have a weird relationship with sidecars and other things. Ideally, if we change that at some point to Kubernetes jobs, it should be completely transparent to the end users.
Okay, thank you.
And to speak a little bit more about the declarative approach, there's actually, I guess, 3 projects now, which their goal is to provide a declarative API on top of Brigade. So essentially, you can write your own Brigade worker. That's the thing that knows what to execute. There are people who are reading YAML in the Brigade worker, and they have their custom definition. There's a project that does a CRD for Brigade events, and they define the job as a CRD. It's up to you, ultimately.
Just one follow-up. So can you also compare to like things like Ballerina or Pulumi and these types of projects?
That's an interesting one. It's ultimately, Pulumi, for example, its goal is to declare cloud resources regardless of what environment they're running in, right? Running Brigade scripts is purposed on Kubernetes only. That's probably one of the biggest differences.
So you said you have some kind of complicated relationship with sidecars. So do you support pods or jobs with sidecars that would like have a vault manager sidecar that pulls credentials for the job, and then is a long-running sidecar actually, but needs to terminate with the main job, something like that?
So the short answer for that is no. The long answer is we have an init container for jobs that you can create, that you can define.
Okay.
And we do not have a sidecar exactly because in Kubernetes, if you have a sidecar, you have 2 containers in a pod. You cannot define which one gives the life cycle of the pod.
Yeah, that's right. That's our current problem.
We're thinking about it, but ultimately it would give us the option to probably specify that this container is the main one. If the user doesn't automatically kill the other, then you have a thing that's running forever, right? We try to avoid allowing users to shoot themselves in the foot. Feel free to comment on the issue. We've have a lot of discussion specifically for this. We'd love to have examples and use cases specifically for it.
Thank you.
Ivan?
So I'm just wondering about the availability of the basically being able to access this to create a storage drive. So I'm missing the name of the Kubernetes API, which you basically call for that. But basically being able to instantiate different objects of the cloud provider, be it a hard drive or anything, would that be possible with Brigade?
To instantiate
an
objects outside of Kubernetes?
Yes, correct. And then bind it to a node probably or something like this.
So technically, in a Brigade job, you can execute any container, right? If you have the, it doesn't use directly the, well, that's an interesting question because you could do that as well. So Node.js has a Kubernetes client. So technically, in the brigade.js file, you can use the Kubernetes API to do anything you need to. So you can access any API in the Brigade JavaScript file. If you don't want to use the API, you can use a container that has kube control. And because you're in the cluster, you're in the same cluster as the job you're running on. You can also pass a kube config to act as outside clusters. So you have the option there. Does that answer your question?
Yes, thank you.
Quick question. I'm still having trouble imagining use cases for this. So I think the persistent volume use case you mentioned is a good one. Do you have maybe like 3 or 4 others?
So probably the first one that when people hear, oh, pipeline and scripting, the first one is CI/CD, right? That's the first one that comes into mind. And we actually use it extensively for CI/CD. It's also It's also a foundation for other CI/CD platforms. I know personally of at least 3 platforms that are building CIs on top of Brigade. Another one is there are security scanning jobs running every night inside clusters. They scan every application with every container image, and they do that. They do retry policies. If there's critical security vulnerabilities, they send an email to someone, right? You have the ability to do that. Other one, which is really interesting, is aggregating data from multiple sources. So they have scheduled jobs that connect to a storage account in Cloud A, to a storage bucket in Cloud B, and to a local MySQL running somewhere. They aggregate the data and generate reports. Another one, which is really interesting, is as part of the CI process to spin preview environments. So essentially, you build the application, create a separate namespace for it, deploy everything, maybe use a service mesh to start directing traffic as a canary, maybe not if you don't have one. Have someone actually validate that the namespace in the application is running correctly, and then simply delete it in the end. Those are some that we see recurrently. There are other really interesting ones. There's someone who's running 8-hour jobs on top of Brigade. They're running nightly. There are various use cases. The reason why I always try to explain the scripting analogy is that's exactly what it is. People usually put it in a box. Oh, CI/CD, or oh, something else, right? Usually there are a lot of use cases that you can have for Brigade.
I had a question about tracing. So if you
could you speak up, please?
Yeah, I had a question about tracing. So these are asynchronous jobs, right? So if you want to incorporate tracing in these Brigade jobs, what are the recommendations to do that?
So specifically, there's an integration with Prometheus to export metrics and everything that Prometheus offers. And right now, we're looking into essentially, if there's a way that you observe your applications on Kubernetes right now, because everything in Brigade is a Kubernetes pod deployment or PVC or storage or anything else that is Kubernetes native, you can keep using that, right? If you have some annotations that you put on resources so that they're observed, then you can continue to do that. We're actively looking into adding documentation for things like Linkerd meshing, right, for Brigade jobs. So you can see when they started, you can observe them the same way as other applications. If there are no more questions, then thank you very much. Please get involved in the community. We're more than happy to help you get started and contribute. Thanks a lot.